Okay, let's take a look at a couple of examples of solving equations that contain rational expressions. Example number 1. 2x over 3x squared minus 12 equals 4 over 6x plus 2. Okay, so what can we do here? Well, there are a couple of things we can do right off the bat to simplify the equation. Notice we've got a 4 here, a 6 here, a 2 here. All of those are even, suggesting we could perhaps cancel a 2. Right? 4 is 2 times 2. Down here we have a factor of 2. If we pull it out, we're left with 3x plus 1. And now those common factors will cancel. We're left with 2x over 3x squared minus 12 on the left-hand side. Here again, we've got 2 times something equals 2, technically times 1 over something. We could divide by 2 on both sides and reduce things even further. So dividing by 2 or multiplying by half on both sides, either way you want to think about it, that 2 is going to go away, right? And we're left with x over 3x squared minus 12 equals 1 over 3x plus 1. So there are some things we can do just to get the numbers down a little bit smaller before proceeding with the rest of the problem. Now, one instinct you might have is to say, well, I'd really hate these denominators here. It'd be great if we could get rid of them. One way we could get rid of them is to multiply both sides by something that would cancel them off. For example, I could multiply by their product, 3x squared minus 12 times 3x plus 1. I could do this on both sides. Okay. Now, there are some risks to doing this particular thing, and I'm going to come back and talk about those in a second. But if we proceeded with that, then the 3x squared minus 12 here and here cancels off. The 3x plus 1 here and here cancels off, and you're left with x times 3x plus 1 equals simply 3x squared minus 12. Okay, the fractions are gone. If I distribute this x, I'm going to be left with a quadratic equation, right? So we have 3x squared plus x, distributing that x to both sides there, both terms, and 3x squared minus 12 on the right. Our first instinct with any sort of quadratic is to pull everything to one side, but of course, as soon as you start to try to pull the 3x squared to the side by subtracting it from both sides, if you subtract 3x squared from both sides, that goes away, as does that, and you are left with, surprisingly, the solution right away. X equals negative 12. Okay. Now, we have to be careful here. Remember I said there were some risks in multiplying by some sort of expression on the left and the right to clear the denominators. One of those risks is, what would happen if this particular value of x made this product that you're multiplying by 0? Then you're effectively taking an equation and multiplying both sides by 0 to find the answer. Okay, that's probably not something you want to do. So we need, if we're going to go this route, we need to check, does negative 12 actually work in this original equation before we started playing with it? Okay, so in terms of a check, let's see, 2 times negative 12 over 3 times negative 12 squared minus 12. Is that equal to 4 over 6 times negative 12 plus 2? All right, well, we'd have to crank it all out. On the left-hand side, of course, we get negative 24 up top. Down below, we get 3 times 144 minus 12. Let's see, that's going to be negative 24 over 420 if we crank that out. And they're both even. In fact, they share a few factors there. That reduces down to negative 4 over 70. Okay, over here on the right, of course, we have 4 over. That'd be negative 72 plus 2, which would be negative 70. and certainly that and that agree. Okay, so x equals negative 12 is indeed a solution to this guy. Now, there's another risk in multiplying both sides by this product, and that is you might be multiplying by too much. If you just take the two denominators and multiply them together, yes, that's going to be a common denominator. Yes, it's going to kill off the two denominators you have present, but it might be a fairly high degree polynomial when everything's multiplied out. If it's too high, then solving the resulting equation might be difficult. This was okay because it was a quadratic, but what if it was a cubic or a quartic? Okay, so there are some difficulties associated with this, although sometimes it can be fast. There's another way we can go that is perhaps a little safer, even though it's a little longer. So let's take a look at that. So starting back with the original problem, we can again cancel some 2's there to get 2x over 3x squared minus 12 equals 2 over 3x plus 1. We can again divide by 2 on both sides, again just to get our numbers a little bit smaller, to have x over 3x squared minus 12 equals 1 over 3x plus 1. But now where do we go from here if we're not going to try to kill off our denominators? Well, one thing you could do, similar to what we did with quadratic equations, is to get a 0 on one side with the hope that you could maybe factor the other side, or maybe that would help. So let's pull everything to one side. We have x over 3x squared minus 12 minus 1 over 3x plus 1 equals 0. Now, of course, this doesn't look like it's easily factorable because we have a difference of two fractions. But what if we combine those two things? What if we actually did the subtraction here by getting common denominators? That, of course, requires that you factor. So this is going to be x over, we can pull a 3 out. That leaves x squared minus 4. Here, there's not much we can do with 3x plus 1. Is this completely factored? Well, no. There's a difference of squares right there. So this is x over 3 times x plus 2 times x minus 2 minus 1 over 3x plus 1 equal to 0. Everything's completely factored now, so I can get a common denominator by adding the missing factors from each denominator. This one is missing 3x plus 1, so let's put it in top and bottom. That's the same as multiplying by a well-chosen value of 1. So I have x times 3x plus 1 over the product of all four of those things. And over here, this one is missing all three of those, so let's put all three of those top and bottom. Again, that's multiplying by a well-chosen value of 1 there. So 3 times x plus 2 times x minus 2, technically times 1, but we don't have to write it, over the 3x plus 1 times those same three factors equals 0. Seeing the common denominators, we can jam them together into a single fraction. With that as the numerator and a rather large denominator. Equals 0. Okay. The top, of course, can be cleaned up quite a bit. We can distribute this x. We can distribute that 3 to this product. Let's see, that's going to give us 3x squared plus x. Here we have 3 distributed to this product. This product, of course, being a difference of squares, is x squared minus 4. So it's going to be minus 3x squared plus 3 times the 4, which is 12. All of that over that common denominator still. Equals 0. Look what happens here. 3x squared and 3x squared cancels off. You're left with x plus 12 in the numerator over 3 times x plus 2 times x minus 2 times 3x plus 1 equals 0. Okay? Now look what we have. We have a fraction Denominator is factored, top is factored, simplified, equaling to 0. The only way a fraction equals 0 is if its numerator is 0. That tells you x has got to be negative 12. And further, notice the denominators up here, which were made up of factors that appear down here, and none of these factors are 0 when x equals negative 12. That's easy to know just by inspection here. Negative 12 plus 2 is negative 10. That's good. Negative 12 minus 2 is negative 14. That's good. Negative 12 times 3 is negative 36 plus 1. That's negative 35. That's not 0. These are all defined. The only way a fraction equals 0 is if the numerator is 0 and, so that you're not in indeterminate form, the denominator is not 0. X equals negative 12 satisfies both of those conditions, and so it is indeed a solution to this original equation. Okay? It's a little more work, but it's a little safer too. All right? Now we can split the difference a little bit. Let's look at one final solution to this problem. Again, the idea here is we're going to split the difference between the two methods to minimize the amount of work, but still kind of stay safe. Okay. So here again, we can reduce things down to, let's see, what do we have before? X over 3x squared minus 12 equals 1 over 3x plus 1. Remember, that came from first canceling 2's here and then dividing both sides by 2's here. Okay. Here again, I'm going to pull everything to one side. So that I have a 0 on the right-hand side. Here again, I want to combine those two things into a single fraction. Normally, we would do that by finding the common denominator. To find the common denominator, we might factor and then ask ourselves what things are missing. Okay. And that's an excellent process to use to keep the common denominator you find as small and simple as possible. But certainly we could just multiply the left-hand side, top and bottom, by this guy. And the right term here, I said left side, left term. The right term here, top and bottom, by this guy to get a common denominator. It may or may not be the simplest one. But doing that would give us x times 3x plus 1 minus 3x squared minus 12 in the numerator, and simply 3x squared minus 12 times 3x plus 1 in the denominator. Okay? Now, again, we need to be careful that the expression we end up with here in the numerator is not too complicated. But notice, you have a linear guy here times x produces that. That's going to be no worse than a quadratic. You have a quadratic times a constant. That's going to be no worse than a quadratic. The difference between the two will be no worse than a quadratic, and quadratics are fairly easy to deal with. So it's okay in this particular situation. But that's something you'd want to check. Okay. Now, let's expand and simplify this. That's going to be 3x squared plus x minus 3x squared plus 12. Okay, over 3x squared minus 12 and 3x plus 1, and that equals 0. 3x squareds drop away. You're left with x plus 12 over this product. Again, you've got a fraction equaling 0. So the numerator had better be 0, which means x would be negative 12, as long as also the denominator is not 0. So you need to double check. If I plug in negative 12 into those two things, do I get a 0 in either case? Well, let's see. 3 times negative 12 squared minus 12, that's 144 times 3 is well over 300. Minus 12 is not going to make a difference. That's not going to be 0. And if I plug negative 12 into here, 3 times negative 12 plus 1, again, that's negative 36 plus 1, that's negative 35. Again, not 0. So this is going to be fine. Okay, that's probably the minimal amount of work to do things safely in a manner where you're less likely to forget about these denominators possibly being 0. Okay? Okay, let's look at another equation involving rational expressions. Example number 2. X squared plus x over x squared minus 1 plus 1 over x minus 1 equals 0. Okay, so notice we have a 0 on one side already. That's nice. If we could combine those two fractions together into a single fraction, then we could focus our attention on when the numerator is equal to 0 and the denominator is not. So let's do that. That, of course, requires we find common denominators. We could just multiply this guy here by x minus 1 over itself, and this guy here by x squared minus 1 over itself. But if we do that, this product here of x squared plus x and x minus 1 is actually going to go cubic on us. So to avoid that, let's factor first before we get our common denominators. X squared plus x over, factoring the bottom, that's a difference of squares, x plus 1 times x minus 1. Over here, there's not much to do. You just have a single x minus 1. This denominator is not missing anything that this one has. This denominator is missing an x plus 1. So let's go ahead and add in, or multiply by, an x plus 1 top and bottom on that second term. So x squared plus x over x plus 1 times x minus 1. That's going to stay the same. Over here we'll pick up an x plus 1 over x plus 1 times x minus 1. There again is our well-chosen value of 1. They have common denominators now, so we can add them together. We have an x squared. We have an x here. We have an x here. That's 2x. And, of course, we have a plus 1 over x plus 1 times x minus 1 equals 0. Okay? So if we have a fraction equal to 0, the numerator has to be 0, and the denominator has to not be 0. If the numerator was 0, then x squared plus 2x plus 1 would equal 0. That's a quadratic. We know how to solve such things. Try to factor first. And sure enough, this factors very cleanly. It's a special product. It's the square of a binomial. It's x plus 1 squared. You can take a square to both sides if you want. And then very quickly we deduce x must be negative 1. So the numerator here is going to be 0 when x is negative 1, but that's not enough to equal 0. The denominator has to be non-zero. But if I put in negative 1 right here, I've got a problem. The denominator is 0. And in fact, going all the way back to the original problem, this denominator here would be 0. So this, while appearing to be a solution, actually isn't. And this equation has no solution. Okay? That's it.